Hi everybody, it's Professor Mitchell. We're starting a new chapter today, Chapter 7 on sampling and sampling distributions. So we'll start briefly with this section 7.1. I think it's just this one slide. Why sample? So remember that a population represents all possible subjects of interest, whereas a sample is just a subset of the population. So why sample? Why not look at the whole population? Well, examining the entire population would be expensive and time-consuming, and you can't examine everything if the test is destructive. So if a sample is selected properly and the analysis performed correctly, sample information can be used to make an accurate assessment of the entire population. All right, so this is the section that I really wanted to talk about today, types of sampling. So when you're sampling from a population, there are probability sampling techniques, and those are the types that we usually prefer. There is simple random sampling, systematic sampling, stratified sampling, and cluster sampling. I'm going to pay special attention to those two because they sound kind of similar. And then resampling. And then if a probability sampling technique is not available, you can do something like convenience sampling. It's not as good, but maybe better than nothing. All right, so first of all, a probability sample is a sample in which each member of the population has a known non-zero chance of being selected for the sample. And the advantage of probability sampling is that you can perform inferential statistical tests to draw reliable conclusions about the population. A simple random sample is a sample in which every member of the population has an equal chance of being chosen. I'm not going to really talk about this slide. In an introductory business statistics class, we don't usually do too much practice with actually drawing the samples. We just talk about what are some of the better ways of doing it, but we don't actually do it. But if you're interested or you ever need to do it, just know that you can have Excel help you pick your samples. All right, and that's just more about Excel. Note the difference between sampling with replacement and without replacement. We've talked about that before. All right, so in systematic sampling, every kth member of the population is chosen for the sample. The value of k is determined by dividing the size of the population, which is usually called capital N, by the size of the sample, little n. So here's the formula for your systematic sampling constant. I've never heard it go by such an impressive sounding name before. Where again, capital N is the size of your population, little n is the size of your sample. So for example, if you were selecting a systematic sample of size 10 from a population of 1,800 students, since 1,800 is divided by 10, you would choose every 180th student for the sample. Now, so let's say you had a list of the students. That doesn't necessarily mean that you have to pick student number 180, student number 360, student number 540, et cetera, et cetera. What you can do, and really, you might need to do this in order to make sure that these are simple random samples, is actually choose a random number from 1 to 180, let's say 67. Choose the 67th student and then every 180th student after that, okay? And then that way everybody truly does have an equal chance of being chosen. If you always choose the every 180th student starting at number 180, well, you're going to get the same sample every single time if your list of students is in, say, alphabetical order, okay? So just thought I'd throw that in there. All right, again, instructions on how to use Excel. to help with systematic sampling. The advantages of systematic sampling are it's easy to do manually, and you can avoid bias by not allowing judgment or convenience to affect the sample. In other words, pick your random number from 1 to 180. After that, I'm not paying any attention to who does or doesn't get into the sample. Some disadvantages of systematic sampling, one of them is called periodicity, which is a pattern in the population that is consistent with the value of K. For example, sampling every 8 hours might obtain values only from the beginning or end of a shift, which might not be representative of all values during. All right. Next, we have stratified sampling, which again may sound kind of similar to cluster sampling. So I really want to emphasize the difference between the two. So with stratified sampling, you divide the population into mutually exclusive groups called strata. Strata is a Latin word that means layer. A random sample from each strata is selected, and the strata are based on important variables that can have an impact on the data collected and the results that are achieved. So one thing that I will add to this, and you'll see this in the example, when you divide your population into these strata, the strata themselves are not representative of the population. For example, for an undergraduate population, your strata could be class standing, freshman, sophomore, junior, senior. For factory production, strata could be first shift, second shift, third shift. For a population of workers, strata might be different age categories of workers. So obviously, all freshmen is not a representative sample of all students. All third shift workers is not a representative sample of all workers. All workers under 30 is not a representative sample of all workers. So what you do is after you divide your population into these strata, you pick a random sample from each strata. So some of the people in each strata. Using stratified sampling helps ensure that all classes, shifts, or ages are represented in the sample. So compare that to cluster sampling. Cluster sampling involves dividing the population into mutually exclusive groups, so that part is the same, or clusters that are each representative of the population. So that's the first big difference, is these clusters. Each one of them is a representative sample. And then what you do is you randomly select some of these clusters to form the final sample. In other words, all of the elements within that cluster get selected. These clusters are often selected based on geography to help simplify the sampling process. So I remember one example of cluster sampling that I've seen in another book is city blocks. Now you have to be careful because city blocks, one city block is not necessarily representative of the whole population, right? Depending on its location, if it's in a very affluent area or a less affluent area. So you want to be careful about that. Some other examples, individually boxed packages of bulk parts in a large delivery from a supplier. So, as long as all the different bulk parts are in one box, then you could select some of those boxes. Individual cities where a new product is introduced, or I really like this one, customer account balances arranged in clusters by first letter of last name. So I'd say for the most part, everybody whose last name starts with M is probably pretty representative of the population in general. Okay, nothing too special about the letter M. Okay, so they kind of feel the same way about this that I do, that it's easy to get stratified and cluster sampling mixed up. So they've got a special slide for that. Again, strata are defined with a common characteristic. The values have something in common, such as each student being a freshman. Strata tend to be homogeneous collections, each with a certain characteristic of interest. Whereas clusters are mini subsets of the larger population. Again, each cluster is a good representative sample. They tend to be a combination of various characteristics, so that would make them heterogeneous, right? And again, each cluster should be representative of the entire population. Excuse me, that brings us to resampling. Resampling is a statistical technique where many samples are repeatedly drawn from a population. One type of resampling method is the bootstrap method. It involves using computer software to extract many samples with replacement in order to estimate a parameter of the population, such as the mean or proportion. All right, and that brings us to our non-probability sampling technique, a sample in which the probability of a population member being selected for the sample is not known. So the example that we'll talk about is convenience sampling. Convenience sampling is used when sample values are selected simply because they are easily accessible. So imagine standing outside the library and surveying the first 100 students that happen to walk by. So you see this done all the time. That would be a convenience sample. I'm asking those particular 100 people because it's convenient. They happen to be walking right by me. The advantages are it's quick and easy to get sample data, and it provides general information about the population. However, it may not be representative of the population. If I'm standing outside the library with my clipboard at 8 a.m., it's very likely I'm not going to get a sample that's all that representative because maybe a certain type of student goes to the library at 8 o'clock in the morning, okay? So that's just something to consider. I believe that is the end of section 7.2. Let's double check. Yes, it is. So we'll pick it up there next time and we'll see you then.